So, welcome to our presentation on the Pi Law and our experiences so far in developing. Briefly, we're just going to first of all go over where Raspberry Pi is, who we are, what it is supposed to be for, the history and motivation behind its production, what it actually can do, all of its capabilities, what people are actually using it for, projects, both amateur and professional, of course, and what we've done with it. So a real world example, and then some conclusions as well. So, first of all, this is a Raspberry Pi. If you didn't have a case on, you can think of it as a very small, naked computer. You can connect it to any HDMI device. It's got Ethernet connection, and it's got USB ports, so you can connect keyboards, Wi-Fi, any other kinds of devices to it. So, does everybody know? Has everybody seen one of these before? Do you know what it is? Right. Right. Who we are? Well, we're real-time software engineers, and we work at the Current Science Centre. We're working on nuclear fusion research. That program has been going for since the 70s. I think we started to build it, and then it's been definitely going since the 80s. It's still probably about 50 years away if I look out from producing fusion energy, but that's another presentation.
10 years. Anybody who wishes to buy fusion-generated electricity, you see the addons. I have no connection with your next speaker.
So we have to thank CCFE because they have lent us these monitors and stands so that we can come and show you these things this evening. And they've also been quite supportive in using the technology at JET itself. So we can understand that. So my name is Goodyear. It says on there that I make hardware. I can't tinker with hardware. I'm not software orientated. And then, of course, there's Colin Humblin here, who's also a software engineer. Adam, it says he makes PowerPoint, but he's also a software engineer. Okay, so the idea that came about August last year, and I was leaving JET one evening, and there was an open evening, and they had all the visitors coming along. And there was one tiny little 14-inch screen on the table, and there was about 50 people crowded around it trying to watch what the video was that was on it. And the video was also postcard size. They haven't even expanded it to full screen. And I just thought, this is ridiculous. There should be a video. So that's where the inspiration came from. And Colin and I set about producing it. You can buy these commercial off-the-shelf solutions, but I think even 20,000 is a relatively small amount of money. You can pay for these systems. Screens are very expensive, but the computer systems to run them are also very, very expensive. So we did a DIY solution to a 9-screen system, and including the screens, we came in at around £2,500, and a stand for that as well, quite a fancy stand. It's horrible, but it's quite fancy. And Adam recently joined us with his sort of renewed interest in business and things, so hopefully he's going to help us actually make something of it. So a bit of the Raspberry Pi history. Why did it even come about? What was the motivation behind it? It started with Cambridge University. Wrong venue. Okay. And some lecturers there, especially people who were responsible for new student intakes, noticed that in the 10 years up to 2005, when they were involved in the new student intake, that the students were becoming less and less computer literate. So they went from knowing one or two assembly languages to knowing some web programming, and so suddenly they were taking many weeks to try and get these students, these new recruits, up to the same standard that they were 10 years ago when they arrived through the door, and that they were finding that quite difficult. So they realised there was a problem, and they wanted to know why this was. The theory was that back in the 80s, with the home computers, the BBCs and the Sinclair Spectrums and so on, and the Commodores and the Ataris, that they were far more available for everybody and the children to play with, to begin with, and play games on. Many children migrated into trying to do the programming themselves, and that may have started with just typing the programs in, copying them out of magazines, which is how many of us started. And it grew from that. So the kids taught themselves, and they became more interested and wanted to go on these courses. That was the other thing as well. The figures for the number of students applying for computer science at Cambridge dropped by 50% over those 2 years as well. So not only were the candidates not very good quality, they were also not anywhere. So what happened? So it must be they think that something happened to cause this, and it's this slew from about the 1990s where you come away from computers that are meant for the home, and you end up with PCs and also gaming machines. And so those are very closed, they don't have keyboards or mice, and you don't know how they work. You just buy your cartridge or your CD, you plug it in, and you play your game. And there's nothing there for the children to interact with or to change. So they identified this need for a new sort of personal computing platform for children. And so, as a one thing really that they felt was good enough, the Arduino was around and things, and that's a very small device that's based on micro technology. It's got a lot of input and output pipes and so on, but it's not very powerful. It can't run Linux or a proper operating system or anything like that. And they wanted something that they thought the kids could engage with, so you need good graphics to be able to play the games, but to give them something else that they could tinker with as well. And it needed to be cheap, so they thought, right, mobile phones, they've got good graphics on them, and they've got enough power to run Linux and so on. And so they chose that. Right, so the people behind the pipe, the champion is Ivan Upton. He goes around the world preaching the gospel of the pie to everybody. And he's incredibly successful at doing that. He was one of the people who originally identified the problem that he felt was in education at the time. And together with people like David Braverman, who anyone who had a BBC knows that he wrote the Elite game, and so he works for Broadcom, the chip manufacturer, who were also heavily involved in helping out here. And then Pete Lomas, who is also another engineering person from technology. So at this stage, I'm going to hand over to Adam, and he's going to tell you more about how the education and the business growth for the Pi state.
So yeah, these guys put together this system, and they did a lot of work getting it out, and it's taken off so exponentially since it's become available and people understood what you can do with it. The Google Trends graph there is one of the figures, which is sort of 2010 to 2013. It seems to be a very popular story. I mean, this story that Alex has summarised, it really seems to grab the attention. It gets a lot of media, both the conventional media and also the sort of up-to-date modern tech sites are also covering this a lot. The bottom graph shows the distribution where this is really going, heavily in Europe, also in the States. There are some issues with getting devices to some of the other areas, but that's starting to take up as well. So, to support that, I mean, originally their expectations were maybe sell 10,000 over a year or so. And by exponential, I really do mean that. I mean, they have now sold more than 1.75 million of these devices. They made the first 750,000 in China. They had to go out there to get fabrication done. They knew they had to get a certain volume to make the cost low enough so they could be targeting the market they were aiming at. But given the volumes they were doing, they've been able to move production into the UK. And Wales, which has recently made its millionth Pi, I think that's getting a gold box at IHQ. And they're hiring a lot of people, and it's producing a lot of economic benefit. Now, the original aim, as Alex indicated, was to try and overcome this limitation in the quality of computer science faculties. And so they really were trying to drive educational goals. They wanted kids to think a bit more about what's behind a computer. It's not just a start button and an Internet Explorer, but what makes that happen. They've got a lot of support, which is available more widely on other computing platforms for engaging children in programming. Programs like Scratch, comes out of MIT, graphical programming environment, very easy to describe block structures and to move animated characters around the screen, make little games, little movies. But they've also supported Python, which you may know is designed to be a programming language for teaching, for learning. But it also scales. So whereas with Scratch you can make a game, but you're probably not going to control anything serious. With Python you can solve lots of real-world problems. When you would power on one of these devices, you see the whole Linux startup set of messages. They leave it raw to get kids engaged. So that's what it means to see all these things happen. And they don't initially give you the graphical environment that you can see running on our display here. They just leave you at the command line. You only have to type startx to get a safe code, but at least you have to type that, and you have to ask what does that mean? And what else might you be able to type instead? In particular, as well as giving a powerful computing platform with good graphics, they've got nice ways to interface with electronics, so you can get into real-world projects as well. So that's what they thought it would do, and it is achieving that aim. There's an organisation called Code Club, which have a wide number of after-school club venues where they're trying to teach kids to program. And this is backed by lots of organisations. Raspberry Pi Jams are one of those. But that alone wouldn't really explain how they managed to sell nearly 2 million of these devices. And so the other interest is in sort of maker community. So lots of people are interested in taking devices and making robots or products or just art. Art is an interesting area. Lots of people are just exploring what you can do with the combination of electronics and programmable devices. And they found this is an ideal platform for supporting that kind of activity. And that's down to lots of extremes. You've got groups of people getting together at weekends, all learning about this device, and so you have this sort of social explosion of interest in programming and making interesting projects. Going a little bit further, people have taken the Raspberry Pi and made a whole integrated media center. There's a package you can download and you can turn your old TV into a smart TV. And that also gets quite a lot of sales going. So if you read in an entertainment magazine that for £30 you can have something as good as the Sony £300 equivalent, then you'd be quite interested in ordering one of these devices. So I just said a little bit about the capabilities already. It's an ARM processor, running 700 megahertz, where you can overclock it to a gigahertz. Contains a BBC, very successful architecture for CPUs. A little bit limited on memory, 512 megabytes. And then you can plug in your SD card. One of the ideas was, although you spend 20 or 30 pounds on this small computer, you've probably got all the other peripherals lying around that you need to make it into a usable computing system. You've probably got some old SD cards from your camp. That means, of course, these days on an SD card you can easily afford a 30 gig card, so you can put all kinds of data on there. Movies not a problem. It runs Linux. There are other operating systems. In fact, there's a very nice little tutorial on the Cambridge University site that takes you through the process of writing your operating system in assembly language. And within a few hours, you can have the board booting up, you can flash the LED without having to write even a line of C. I went through that and I really regretted not having done more assembly. It's inspiring. It's got Ethernet, obviously, so you can communicate, you can plug it into the internet, which is very important for being able to share projects with other people who've done it. And through the USB interface, you can get access to a very, very wide range of peripherals. We've got the Pi. Yeah. So the little set of pins that you see at the side, the I/O pins, you can do serial, you can do I2C, USB-R. So if you've got some electronics knowledge, you can hook these things up to lots of other interesting devices, and there's good support for that. And the GPU is very powerful. It's actually more powerful than the CPU, and that gives you both access to full HD video, games, and maybe if you're clever, you can use it for other purposes as well. So what have people done with it? Another factor is it's designed to take 5-volt supply, which could be from your mobile phone charger, normally here, but any other way of providing a small amount of power. It's about 2.5 watts you need. So if you put some AA batteries together, or you get some voltage regulators if you want to electronics, so you can power these things without having to have mains electricity, right? So people have put them on hydrogen balloons with a camera, send them up to about 40 kilometers and take us some nice space photos. University of Southampton put 64 of them together to make a sort of model supercomputer. So you had about a gigaflop of performance, about a terabyte of flash. Not terribly powerful, but for 2,500 pounds, it was a very nice exploratory environment where you could look at the ideas of parallel computing. In our domain, this company called Robotech looking very much at maybe robot sort of applications. That's quite an interesting case. So you can either think, I've got my computer, what do I do to expand it? You add some LEDs, and you think of the LEDs as the expansion. Or you can take quite a sophisticated board that just happens to need a small CPU, and you can build on this as your small CPU, and you have network and graphics capabilities. So it's kind of an inverse add-on. Then another example I'd like to explain in our area, in nuclear fusion, is Frascati. So this is some work done by a colleague called Luca Boccani. Now he does a control system. The picture in the bottom left is a small top mine in Italy. And he runs the whole control system for that using an open source real-time C++ framework called Mark, with a multi-threaded application for real-time execution. And he gets students coming, and they have to go through the learning curve of how you use this framework. And he wanted to reduce that time. So he asked himself, could he port this framework to run on a Raspberry Pi? He found it was actually fairly straightforward to do that. And so now he can give these students a Raspberry Pi with an SD card, pre-formatted with this framework. They can go away, they can play with it. And to motivate them, he said, look, you can go and do some home automation, some robotics or something. And the project he set up himself, being a keen homebrew expert, was he automated his own brewery system using Raspberry Pi with this application. So the diagram here, he's got a circulating wort, and he needs to apply some good temperature control. And being a bit of an academic, he went into this in some detail. He looked up all the chemical reactions and what kind of temperatures you needed for what kind of periods to get the enzymes working to get a good flavor, for example. And then he wrote a control algorithm in this real-time execution framework, plugged in his Raspberry Pi to his heater, and he's produced some very good beer. And some of the graphs and traces are some of the things he's written up on that. You can do all kinds of things. It's a sort of fun project, but it really shows that you can take lots of codes and run them on the ARM. It's a very easy environment to work with. This idea of just giving away a device with the whole, I mean, you don't have to do anything. You can give people a USB stick and say, put this in your laptop and you can set up maybe a live environment. But you can go further, just give them the whole computing platform. It doesn't actually cost that much more. You can motivate people by saying you can control real-world stuff. You can make a little brewery. And actually, the performance was very decent. At Jet, I've got a magnetics real-time control system. We've had it for about 10 years, so I've got a PowerPC, 400 megahertz, 512 megabytes of memory. This is just about as powerful. It's a really useful piece of computing. And actually, in terms of business, this guy's kit, I asked him, can I sell this idea? And he said, sure, just give me 10%. So a little micro business for us to follow up. And people are doing it. So it's designed for education, but you can make really neat stuff with it. And people want to buy really neat stuff, so why not make some money on the side? And the Pi Foundation, in practice, they have no objection to this whatsoever. That it may act as a way to motivate the kids. Why should I learn to program a Raspberry Pi? Well, maybe you could get rich. That might be one of the drivers for some people. So there are companies making a lot of add-ons. I mean, you can see that when you buy the Pi, you get just the computing board. In this case, there's something else that you buy from another company. Lots of kits, cases, lots of I/O, lots of electronic boards that you can put on top of it. People are working on displays that you can actually start to make your own tablet. They've got these little HDMI screen. You can try to sell software. There is a Pi Store. I don't know if it's on the screen here, but there is a Pi Store. It's a bit like the App Store. Obviously, 2 million is a lot of these if you're only expecting to sell 10,000, but compared to iPhones, it's not quite there yet, but maybe one day. You can give away stuff that you've done open source, and then you can have people come back to you for consultants. It's quite a good model for a gamer. And maybe you can get people to club together and offer a bounty or something that can enhance the features of one of the products that you're working on. All kinds of different ways you can do it. And there are lots of companies making products with it. Once you go beyond a sort of project that's just something unique that you want to share, and you start thinking about selling to consumers, there are some sort of more real-world issues you need to start thinking about. If you want to sell anything in the European Union, it needs to have a CE mark if it's electronic, so it may have any kind of emissions that could interfere with other devices. The Raspberry Pi has been qualified, it has a CE mark. They have to go through quite a lot of work to do that. The photograph there is an anechoic chamber where they did some of the particular emissions tests, and so fire lots of radio frequency energy at it to make sure it can withstand and continue to operate normally. There are questions though, if you built it together with other electronics and you want to sell that onto a product, you may need to do some more testing. And then you come down to practicalities, like if you were to manufacture and sell these things around the world, how do you price it, how do you get volume of sales that are going to make it, in order to do it, how do you fund that if you're trying to get started. So you need a combination of skills if you're going to set up a company like this. You need some understanding of what it means to program in an embedded system. So there's no hard disk on this. You can plug one in, but for a lot of products that starts to be kind of unwieldy. So working with slightly limited resources, you need to know a little bit of that. And particularly need some electronics expertise if you're going to hook it up to other things in the world. And if you're going to start making cases and making real products, then you need some kind of mechanical skills and some understanding of 3D CAD fabrication perhaps. And that's becoming increasingly easy to do as well. There are lots of places where you can send your designs, have them cut out, laser cut for you, put them together. We have an example of that here. So once you've got lots of pies, and by the way, our wall can scale as large as you want. We've done a 2x2 tonight, but if you wanted to do a 20x20, if you had the money, it'll work technically. But then you come with the problem of what do you do with all the units. So Alex has designed this case to host up to 6 pies, and also the network equipment, and deal with all the power. And the idea is you have a number of these modules that you're then plugging through the screens. And this is how we're starting to build the product that we're trying to produce. So that, I'll just go back to that supply story. I talked about that already. How to get funding? So, how many people have heard of Kickstarter in the audience? Good. It's nice to hear that somebody has. We've been speaking to lots of people, we've been speaking to banks, and we say, we're using Kickstarter as a way of getting our orders, and they say, what's Kickstarter? And it's just, they're going to wake up one of these days and get a shock. So I think it's $680,000 raised on Kickstarter for these kind of projects in the last year or so. They typically are, well, I mean, Kickstarter is funding a lot of creative projects, but in the areas of products and electronics, I think that's the main figure. These are some examples, cases, the Raspberry Pi, and a camera, a micro SD card plug-in, a little ATX motherboard that you can put your Pi on and build a computer. That's a nice one. My daughter likes that. This is where you put a Raspberry Pi and some motors, and you can send a text message and send your dog a biscuit from school or from work. People making video games that are built on a Raspberry Pi inside, but old style arcade, or sort of Lego Mindstorms with Raspberry Pi. So lots and lots of people exploiting this. So I'm going to hand over to Colin to tell you a little bit about what was involved in developing software. He and Alex did all good hardware. I just made the good hardware, but he's going to say something about how he got this work and something about the legalities of the sort of software licensing. And then I'll come back to the show.
Yes, well, after we had our first realisation of what we could do with Raspberry Pi, we did a little demo. We hijacked all the monitors in the control room of Jet, and a video playing, and our boss and other people saw this and thought this is something in this, and both our department and other instrumental in getting this a video wall put in our foyer. A 9-screen system, which is our first major installation, and used these monitors, which we found a good price for that size of screen. And each one has a Raspberry Pi spanning that portion of the screen, and then there's another one which drives the whole system. To close these 10 Raspberry Pis, we use a standard PC case with some internal modifications which has worked out using the shells and attaching lines, which was a bit silly, which is now looking at the PC system much easier. To mount the monitors, we found a commercial 9-screen monitor stand. So we bought it, and then we found that once you put monitors on, the stand starts to flex in 3 different ways. And the thing becomes 4 different ways the monitors. And then it twists as well, so once you start mounting the monitors on, with a reach joint line. So that was not the most successful thing. And in the second installation of JET, which was the CCFE, which was in the Materials Research Lab, the monitors have been mounted on a large board, which is a lot more successful. So, that's one of the things we learned by painful experience. Reliability issues. When you turn the power off, there is a risk with the SD card that there's unwritten data that has to be put into the card, and the card can get corrupted. So we've had to find some solutions. Alex provides a system where when you boot up again, you can detect the partitions being corrupted, then you switch to an alternative one, and copy back the good partition over the bad one. We also look at another strategy, which is to use it as a read-only mode, in which case there won't be any problems writing for this chip power device. So this system has really made quite an impact. I've already been showing various videos on the rolling loop. Various people come to JET to film and they make videos of it, so we've been showing some of those. And also when the operators have been shown static displays using the desktop hearing technology, ENC, to show the status of what's going on in the experiment. We're intending to develop that to refer to a switch display when there's a pulse running through and shows the plasma, the video, plus stated information. There's so many things that we do that people have to provide our time to work on. So the software that we've been developing, we want to obviously make the profit we can from the system. So we want to release it on the proprietary model, so people pay us for our system with the box and the software. But we also recognise there's some mileage to be made in making some of the software available free, so that people can try it out without having to make an investment or a full video wall, which might put people off even trying it out. But for the paid version, we're keeping back some of our sexier features to make that more attractive. We recognise people want more than just videos and So, licensing. Possibly like many of us have been many years making use of free software, not really bothering with exact terms. Now come to releasing our own software, then we have to use it more seriously. If we're using GPL code, then if we really distribute our code which uses that, then we would have to release all our source code, and then somebody else can do that by being free. So we don't want to do that. However, all of the software we use is actually under the LGPL, the lesser Bloom public license, which does allow for using it in combination with party software. So we've had to do a little bit of pre-party stuff, but generally using our own code from scratch in combination with LGPL libraries. So this gives us, I think, the best trade-off of licensing issues.
I think the last point is to say we're not exclusively investing our time in writing code that we hope is going to make money for us. We are sharing back to a certain extent to projects where we've made additions which will support the free version, which I think I said it's not just to get people interested or to let them try it out. I mean, there's quite a big difference between somebody who wants to put together a VO or maybe just for the sake of a demonstration on an evening like this, where reliability is not such an issue. You have to reboot the system, your audience wouldn't be that fast. Whereas if you've got an installation that's supposed to be working 24/7 and it's doing something that supports your business and you're trying to make money out of it, then it wants to be really reliable and professional, and you won't object to paying somebody for doing the extra work to get that degree of service. So that's kind of how we're positioning ourselves. So, next one, I think the slides come back to me. So I really do like PowerPoint. It's very much more of his time actually producing the really useful stuff, which is of course this sort of stuff. So we talk about licensing in terms of software and the rights that apply there. In terms of commercialization, the fact that this work came out of our day job at CCFE, we did go to our business development unit. At CCFE, although it's a government lab, it is starting to have a slightly more commercial approach. We operate the jet tokamak here at the Fusion Research Facility on behalf of the European states. But it's going to run for perhaps another 5 years or so, and the project that we're really engaged in beyond that is a worldwide project. And there Europe and the national labs have to compete for work to design and build and operate that. And it's done on a sort of internal market basis. You have to bid for projects, you have to gain funding. So we went to our business development unit and said, well, we've made this system, it could be commercialized. If that's something you'd like to work on with us, and they had a look at that. But Government Fusion Research Lab is not really in the business of selling video walls. So they said, well, we're very happy if you want to take this as a private concern. Good luck, and we'll continue to support you as long as we can have access to your technology for internal purposes, and we have a good agreement that we're working on. So to make this available, either to sort of free use, but particularly to what we hope will be paying customers, we have set up a company. We call it Innovation Limited. We're hoping, perhaps optimistically, to do infinite amounts of innovation. The three of us, that's going to be all over, but maybe we'll get more people involved. The kind of ethos of the work we might have that it's trying to inspire young people to get involved in interesting projects. That's important to us. We do want to contribute back to recognise the fact that we're basing our work on something that's been given away for free by the people, the engineers who invented the platform. We're interested in creating jobs for young people if we can. And we want to sort of reinvest anything that comes out of this for creative, useful, probably fun solutions to interesting, challenging problems. So we gave this away a couple of months ago, August time maybe?
Beginning of September.
Yeah. Just had quite a lot of interest. There were about 30,000 hits on the YouTube movie. And after we've made the vegan packages available for free download, if you want to try this, just go to our site, you can download it. It's done a great job on packaging it. Really easy to install. And we've got some good instructions. We wrote to a number of tech sites that suggested they might be interested in working on the story. And Hackaday was up on that. So our traffic spiked hugely. We had about 22k hits since then, but there were about 5k visitors within 2 or 3 days. And a couple hundred downloads, I think, of the software. The forum where we try and answer technical questions, but we also encourage the people who are experimenting with our free package to try and answer their own questions if they can. That's starting to work quite well. We're starting to develop a bit of a community that can be self-supporting. Because there are only 3 of us. We do have day jobs. Quite a lot of interested people for sort of licensing software, asking how they could be involved in commercializing it, and we're keeping that in mind. A very nice feature is we've had some voluntary donations, people offering us some money just in thanks for the fact that they were able to download something and get something out of it. This is a really nice way of people interacting. Rather than being just a commercial company and you're looking at customers who come somewhere and buy your product, you're just actually trying to engage with people. It's something I do myself. I'm trying to learn some electronics to be able to do this interfacing stuff. There's an Australian engineer who makes a very nice series of videos on YouTube, and I pay him $2 a month because I really enjoy his stuff. There's no obligation on me to do that, I just like it. We've had a little bit of consultancy work to come out of this as well. We're particularly small projects really appeal to us, and we engage with the people through email and we took on a little bit of work. One of those, this was a consultancy project, this is actually more kind of a test case. So we gave away our software. Could anybody do anything with it? There was a lot of interest, and there was an IT department in a city in Canada wrote to us and said, we've got a big city celebration, it's our city centenary, and we've all been asked to do something interesting. And we saw your project, we thought we'd like to have a go at it. So these guys put together a 4x3 wall, and they downloaded our software, and with a little bit of email help, a little bit of debugging of our instructions, they were able to get their project together, and that worked really well. We did that on a free basis, but they were very generous. They made us a nice donation after that, so we're quite impressed. So what are we doing next? As Alex has indicated, these are some of this very nice names which we've had laser cut and put together. We think this is a good way of making it practical to build systems and easy to maintain. And we're going to hopefully use Kickstarter to get interested in a large enough set of orders for a system based on that case that we can go off and produce maybe 50 or 100 units, something like that. That's the kind of size we're hoping for. And that will give us, that exercise will also teach us something about how you do this in the real world and give us some experience. Beyond that, we know that we've got a lot of work to do. We've got to check these sort of compliance issues. There are also directives you have to be aware of and you have to comply with if you're going to start selling products around the world. You've got to get your costing right. There's a lot of Kickstarter projects that are very, very popular, very successful, and the people run into trouble on delivery because they've underestimated either the costs at the time, or particularly the time. If you say you can mail out a product to everybody who buys one, and suddenly you get 25,000 people, it adds up. Marketing's not really a word that I guess any of us are particularly comfortable with. 20 years R&D experience, but it's something you have to do. If you're going to engage people, you've got to have interesting ways of getting them involved in your project. And this sort of fulfillment project, you have to really plan again, and we're engaged in that process. And then you've got to understand what are the people out there who can help you. So what do you do yourself? What do you go to a third party to help you? So manufacturing. Do we go buy a laser cutter? Or do we just upload our design to a laser cutting service? These are all questions we're looking at. I think beyond that, we're also interested in looking at other applications. This platform is very flexible. Digital signage is a big area. We've got lots of expanded ideas. Apart from just displaying stuff on this video wall, we've got ideas about how you might interact with it. I'm kind of interested in the rugby part. I say sports science, it's actually a karate body. My family are big into karate. My karate instructor is big on training kids. And getting kids to be motivated in exercise is difficult. I don't want my kids to only be programming computers or playing games. Physical exercise is good. So maybe we can put these two things together. Maybe I can develop a sort of strike force monitor and link to their iPhones or whatever, and they can get a score as well as training. Alex is big into sort of home automation. Lots of applications that you can use there. So we hope this will be a fruitful and interesting activity for us over the next few years. So, as I say, last slide. So, thanks for listening. And if you've got any questions, we'd be happy to try and answer them. Just while I think of any questions, we forgot to run the demo. So you've seen the desktop. I promise it's going to run a little movie. This is a...
Yeah, so this one is a VNC got distributed over the Raspberry Pis, and this is it doesn't recognise this Big Buck Bunny, which is also another free version of software.
This is a good movie to show because it's completely open in terms of rights and licensing, and it's a very safe movie. You can show it anything. It's a good choice.
Yes. And this will just scale up as many screens as you want to add. I don't know if you noticed on one of the slides we had, there was a 9-screen and a 6-screen next to it. And the screens were all in different orientations, upside down, sideways, all different types of screens. We had 4:3, 16, 9 screens, 24-inch, 17-inch, and 15-inch. You can mix them any way you want, and the software just sorts out how it looks.
Yeah, I noticed that. That's a fascinating tweak to the implementation.
Yeah. They can overlap each other. You can make art, as Adam mentioned, we had a huge interest from the art community, museums and all sorts of things.
You can have virtual windows on the wall, or it's a way of building quite a big version of art with in-depth. Have you considered a depth attribute?
We haven't, no.
But if you had a flat wall with, you could almost create 3D.
We are getting flat 3D. We've got a project which is driven by our field research. So we do a lot of remote handling, a lot of 3D CAD, and we try and illustrate this problem to visitors. And we've got an actual physical 3D demonstration. But what you can build is very limited compared to what we really had in our machine. And yet we've got all the digital data to do a very nice virtual reality experience for our visitors. And we'd like to be able to do that on the large-scale wall as well. So that's something we will do.
You have one Raspberry Pi per screen, do you?
Yes. Yeah.
Because the box itself is probably quite large. Because I would imagine...
I thought that as well.
People are coming up with these solutions in parallel. So yeah.
So in this box, I've got here, I've gone to a lot of pains to actually make it so that the Raspberry Pis are mounted on some removable sliders. And because we haven't had a lot of failures, we've had one actual Pi fail out of the 18 we've got in about 18 months. But we did have a lot of trouble with the SD cards, so I've made it so that you can get to the SD cards really easily. This will also have a switch in it at the back, so there's enough space for the Ethernet switch to go in. That's why there's 6 Pis, space for 6 Pis in here, plus 2 in and out. I'm testing different connectors here, which is why they don't look the same. But I like the metal surround them better. So that is an 8-port switch. There are 8 connections, and then you just chain these together for as many walls or whatever you want to do. You can just keep adding more on, and you can have just like we've got here, 2 separate walls controlled by 2 separate boxes, but they'll be in perfect synchronization with one another. You can show half the data on one wall, half on another, the full amount of data on another wall. So it can be used in airports, for instance, for the arrivals and departures and so on, all that kind of information. And it's distributed by Ethernet. So there's no expensive cabling or breaking computer closes rooms that you have to have all the air conditioning.
So that's the interface between each Pi, is it? An Ethernet?
Yes.
We get 15 watts if we put 6 of these in there, roughly.
Well, that's if that's at peak power. You're not using anything like that. So I'm using a 4 amp power supply at 5 volts is there with the Ethernet switch as well, and we're nowhere near using the full.
So, I mean, there's no ventilation except
Well,
there are holes, yes.
There is ventilation, but there was a minor measurement error. This made-up infinity symbol, which I admit is a number 8 on its side. This is where the fan was going to be, but I mounted this too close to there, so I couldn't get the fan in. But on the next model, there will be some.
Yeah, I was going to ask, you didn't actually mention what the architecture was of your solution. I assume it's like a distributed Ethernet display driver, and you're displaying the output from your master Pi onto the other screens via other Pis, right? No? All right.
Yes. It doesn't work like that at all.
And maybe that was deliberate, you didn't want to tell us, but I thought if you were presenting to a business audience, they probably might want to know that.
Yeah, it's the UDP multicast of the video stream from the master, and then each Pi receives that and displays its portion.
Okay.
So each Pi receives the whole information, as if it was it's going in H.264 compressed format, and then each Pi will deal with what it's meant to display.
Right.
So that's where the bit of magic happens.
So I guess the main difference over the expensive commercial walls are that they take, for example, a VGA or HDMI input
Yes.
from anything else, whereas your master source is always going to be a Pi. Or
No, it can be anything.
Oh, right.
It can be anything, but it can't be a physical HDMI connection.
it's an Ethernet. It's video over Ethernet, basically.
Yeah, or compressed.
Yeah.
Okay. Yeah. Or it can come from the source, but yes, basically that.
Right. Interesting. Thanks.
Yeah, my question was basically, I come from a teaching background, and I can see this being really useful in the classroom. Not just at the front of the class on projectors, but also distributed around the classroom itself, and perhaps between classrooms. And so, if you're using Ethernet, I take it you can just put that straight onto your local area network, effectively, pipe it across to another room using the infrastructure that's already in the classroom.
You could, but it would probably be not recommended because we use a large bandwidth.
Yeah, I see.
Yeah, so it's, yes, but with caveats.
Yeah. So maybe looking down the line, maybe good to be able to put it onto the sort of
If
network.
you've definitely got giga
Yeah.
internet network, then we're not going to be a problem because we're 100 megabit, and there need to be, we'd have to reserve 100 megabits connection through some managed switches, so that would be something where you could manage to do it.
So you could effectively put on a VLAN or something like that. A VLAN. And then, of course, then we could do it through wireless as well, which would be quite good.
Wireless as well, you'd have to have a very high performance wireless.
Because I mean, obviously, Apple's got their AirPlay system where you can effectively take your iPad, throw it up onto a projector.
Yes.
And that sort of thing. So, it'd be good to, it's good.
Yes, it all depends on the quality of the video you're playing. Something like this Big Book Bunny, that uses the maximum bandwidth on 100 megabit. There's very little left, especially when you're transmitting sound through as well. So, but then when you've got some video which is 720p, for instance, well, there's quite a lot of bandwidth there. So, yes.
And you have to have continuous throughput. Have you tried to buffer it anywhere? So that
No, if you buffer it, this will all they'll start doing their own individual thing. We rely on the throughput to synchronise the screens.
I just wonder if you did actually buffer it. So to the time delay, you could then deal with, as long as you've got some, you could deal with the rest. Just build some plastic into the system.
We removed it from some of it because of the VNC, because of the virtual desktop session, because that has to be live. So we spent a lot of time in improving the performance so that you really could work from this screen with the mouse in front of you and not getting lag, because when we first started you were doing the mouse and then it would go. That was unusable. but now it's fine.
But at the end of the day, that's not the bandwidth is not the problem you're trying to solve. Because if somebody wants something like this, they'll make sure the bandwidth is available because it's the cheapest solution.
Yes.
It's not a networking solution.
And things also that I've been playing with are the Connect system for gesture control in front of the wall, and so you can control what's on it and so on. So that's been interesting. We've also looked up a camera, and we used the Raspberry Pi camera because it's very high performance, much better than a normal USB camera, and it acted like a mirror. So we inverted the image, and it was perfect. And way back, and you tap the camera just sort of in the middle of the person is in the centre there. It's great fun.
Great fun to play.
Oh, the big opportunity here is in the low power usage, because our postal companies really get ripped off by electricity companies for installing power. Your organisation has quite a lot of experience of solar power, doesn't it? And I wondered if you made sure that this was workable, sort of in street environments using solar technology.
Well, we're not solar power experts at all. The fusion energy it works like the sun works. But
Yeah, that's what I mean, trying to copy the sun.
Yes, so one of the reasons that we chose it. But if somebody wants to use that solar power. Yes.
So the speed usage is quite big, but if you go to the paper maybe, of sort of semi-moving displays, then that might be a very good solution.
That's another area we'll have to learn about.
That's where the big market is in shopping streets and bus stops and phone boxes. Phone boxes have their own power supply through the phone, of course, 50 volts. That may be worth experimenting with as well, because they're desperate to get phone boxes working, because advertising will give you time for that.
I was wondering, do we have any installations in public places? Any customers have installed systems?
Well, we've got the Canadians. I don't know how, but it was outside somewhere. And then at Jet, unfortunately, it's in the public area, but to get on site, you've got to get past the security guards.
I've been on a tour twice of Jet, and it's very good. I recommend it. But is there anybody in Oxford, in a shopping centre, for example, interested, or would you loan a system to big department stores?
At the cost, they would quantify department store. £2,500 for a management system. It's not a lot, is it?
We could also afford to learn it. It's not a bad idea.
You've
got a shop.
It's time for the installation, the labour putting one in. For temporary installation, it's quite a lot of work. With just cabling and so on. It actually uses these incredibly power efficient screens, and I wasn't in any danger of overloading even with one single 13-amp socket I put on a measuring device, which is very small device. So
We were talking before we actually what I did to do this is if you go to a TV shop, they've got loads of display, but it is very nice effects.
Yeah. So which sources are supported? So is it just content that originates on a Raspberry Pi, or can you take feeds in some way?
H.264 video stream.
Right.
It can be an external PC, and if you can put stuff fast enough from wherever you're getting it, you can feed it into the network.
You mentioned you have one pipe bailout of your 18 or whatever. I mean, say you get a 9-screen system of this, what's your mean time between failure going to be? You say you want it running 24/7, you've got your one.
We actually don't run 24/7. It starts up at 7 a.m. and shuts down at 10 a.m. each day. And that's partly to test out the start and stop. and also because the screens are not rated to run at 24/7 either, because these are just relatively cheap screens. So
we are looking to detecting failures and automatically reboot. So there's two kind of failure modes. One, your operating system's crashed, you need to remove power to repower the device. We can deal with that quite easily. I guess if the board's going completely, you can have redundant line and you can have some way of switching over to a different HDMI cable. So if you really wanted enough resilience, it wouldn't be that difficult to engineer.
Talking about the screens, I thought you've got some challenges there with commercial off-the-shelf screens with setting them all up to run off the same channel and things like that. Have you found any particularly interesting ones, or to actually solve those sorts of problems? I mean, you mentioned reliability as one of the energy usage. I'd have thought getting them all started and synchronized might be another challenge.
The synchronization comes from the actual pies themselves, so that hasn't been a problem for us. The screens themselves, if you want bezel-less or you want commercially rated screens, then it's just price. Bezel-less, you're talking €7,500 for a 40-inch screen. So I think a small bezel for £100 a screen. But then again, this is just a demonstration. You wouldn't buy 4 24 inches to give you a 48 inch, you just buy a 48 inch screen. But you can attach 4 60 inches to this. Just unplug these and plug the other ones in, and now your wall is huge. So that's the beauty of this system.
I would have thought the obvious market there are things like the trade stands, where they currently have to take in or hire a voltage monitor at £3,000 per event. You could or probably even people who rent those out would be the ideal customer for having these.
Yes. We looked at that. And one of the things was the amount of, for us, for instance, the amount of time you'd have to invest in, and people for taking the kit, setting it up, then going away, then coming back the next day to take it down. There's a huge overhead there.
But they would pre-configure that. They'd have a big panel or section panel or something like that. Which to try and simplify that. And I thought what you want to have is basically a turnkey solution where they have no configuration. They just plug in their laptop or whatever.
Yeah, well, with this tonight, our main time was just setting this bit up and just plugging in the rest of it.
Yeah.
So what we've got down behind here is we've got a PC that we're just using as an extra screen because the master Pi doesn't have a screen at the moment, so that's just an SSH into that. So that's actually doing nothing more than that. And then it's the PC case, and this is the first one I made on my kitchen, dining room table at home. And so the Pis are just mounted in the drive bays, and there's a very strange piece of electronics to con the PC power supply. I think it's got a motherboard in there. And so, yes, not on the same level as hopefully that from down there.
What does the control interface look like to figure out the difference?
At the moment, that's a configuration file, a text-based configuration file, a bit like a standard INI file that you used to find off of Windows systems and things. So we just sort of find a wall, total measurements. It's easy to just get your tape measure out, measure that. Then you measure each one of the screens of what their visible area is.
It's not setting a roadie to not necessarily.
I thought you want a little smartphone app where you just stand in front and take a photo of your screen and it will generate your INI file. And then you just drag as you want things to move around.
But yes, with the pre-configuration stuff.
Yes.
How about the colour settings? I mean, I know HDMI, I think it's got a control interface, so you can tweak the colour balances.
Yeah.
On the screens themselves, because of course with cheaper monitors you've got different levels of
What did you think of this one? Here it's hard, isn't it? Because of the angle.
I shouldn't comment because they're not designed to operate.
No, they've got about 170 maximum.
I mean, it looks pretty good from this angle.
Well, that was out of the box.
Yeah.
There's been no configuration on those screens at all.
But given the cost, I would imagine a lot of people would want to reuse old screens. That might be the way to go. In which case, you would probably have an issue setting colours up.
Yes, that was something that did come up on that random 6-screen wall, and you probably even noticed in the picture there.
Yeah, it's very
different. So yes, but again, I didn't take any time to configure those, and they'd been on someone's desk, being configured to their liking.
That's when I was at the minute. That's something else that's going to go in the when they've got away.
Yes. Another thing people have asked us about is projectors. You can get it even bigger if you shut projectors on and things. And then so we've done a little bit of investigation on edge blending, and so we think we can probably do that too. So that where the edges of the projectors overlap, we're not going to get a bright line because we'll be able to put a dim mask around the edge. I mean, that's how powerful the GPU in there is. In real time, we can also look at the images that affect to it. It's a very impressive piece of kit.
You ever tried mounting one on the ceiling? I'd like to see one above my dentist's chair.
If your dentist is quite rich, we can certainly. In fact, it doesn't have to be rich at all because this is a very reasonable system. Yes, we've thought of many things like that. So, for having a pretend sky or something, my personal favourite is a floor made glass. So you walk out to the middle, and then so it looks like a carpet or wooden floor or something, and then turn it into the Grand Canyon, right? So I think I can have some fun with that one.
But you're not just replacing floors by something alternative. People are looking at making it a wall so it's like a window. Got a guy in Florida who's doing his condo, and he wants to have 4 or 5 rooms where you've got different natural views.
He has no windows, he just has things.
That's not actually natural. That's the opposite of natural.
Yes, he was his chosen.
There's lots of options there. So you've got your hotel room that doesn't have an outside view, one that does. With the internal cabin on a cruise ship, it's got a portal, a virtual portal.
Or a whole balcony.
Yeah.
I think we're getting close to 9 o'clock. Thank you very much for this